All right, guys, so here we go. This is a SL question, exercise 7G number 6 from your Oxford textbook. I've had a couple of requests for this one, so I'm going to work through it with you. HLs, if you are watching this, it's a good question. I recommend that you figure out how to do it. I actually recommend you try to figure it out first, and then you could watch the video to make sure that you've done it right. All right, so you can read the question. You can see the Venn diagram there with some pieces missing. We are going to go straight into letter A. So letter A says, find the probability of B given A. Now, the first thing I'm going to do is I'm going to go ahead and write down that from my formula packet, it's the probability of A given B. So it's actually backwards, okay, but shouldn't matter too much. We're just going to make sure we put the right things in the right places. Right, so this is directly from your formula packet. You can use that, make sure you're comfortable with it. That's the first thing I would do anytime it actually says B given A or A given B or anything given anything, is I would write that down first. Okay, so now I'm going to go straight into part A and try to answer that question. It says B given A, so it's actually the switch of these right here, right? And so we're going to go that the probability of B given A is equal to the probability of B and A. Now this is actually B and A is the same exact thing as A and B, but now on the bottom, instead of dividing by the probability of B, we're going to divide by the probability of A. Okay, the reason being is because it's given that A is true, right? In this case, it was given that B was true, and because B had to be true, we're not looking at the total group anymore, we're only looking at the items that are in B. Same thing here. Given that A must be true, we're not looking at the whole thing anymore. We're only looking at the things that are actually inside of my A circle here. And that may actually be helpful to recognize that it's just looking at these guys right here. Okay? Now, recognize it is probability, but you can use the number of items as well. Right? Because whatever the total number is not significant. You're going to end up dividing by that anyway. Okay, so what I would do here is just go ahead and put these in. We can find the probability of B and A, or not the probability, but we can do the number, right? We can count up how many things are in B and A. So the overlap of B and A would be this section right here, right? And so that's what I'm going to do. That's my B and A. So that's 8 plus 3, which is 11. And then the probability of A goes on the bottom, or the number of things in A, which is just the total of things that are here. So 11 plus 10 is 21. And so there we go. That's our probability of B given A. And that fraction right there is perfectly acceptable as that probability. Okay, let's move on to part B. Part B does a similar thing, but they want the probability of C given A. So again, we look over here at our given probability, and we set it up by saying this is the probability of C and A divided by the probability of A. Okay, same thing as last time. It's the given that needs to go here on the bottom. Once we have that, then we should be able to go straight into our question. This time we're looking at C and A. C and A is this section right here, right? That's the overlap of my C and my A there, which this time is 9. So that would be 9 over, and then the total in A is 21. We know that. All right, so there you go. Then you've got part B. All right, now I'm actually going to jump ahead really quick to part D. It does say to interpret your answers for A and B, and I've got A and B now. What I'm looking at here is that these two, actually, sorry, we do need to do the next part. So we're going to go ahead and do the next part first. I was thinking to compare those two, but that doesn't really do us any good. So let's go ahead and see if we can figure out part C. You are given that PC given B is 10 over 23, and A given C is 1 over 3. So let's go with the 10 over 3 first. So the probability of C given B. Now, if I write that in terms of my formula up here, that would be the probability of C and B, given that B, just like that. Okay, and that has to equal 10 over 23. All right, so what we're going to do is we're going to find the overlap of C and B. Remember, in each of these situations, we could deal with the probability, but you can also deal with the number of items in that slot. Okay, if you're not sure why that works, send me an email and I'll talk you through why, even though the formula is a probability formula, you can actually count up the number of items. Okay, don't go into it blindly. It's a good idea to understand what's going on. But if you're having a hard time understanding why that works, just let me know. I'll help you out with it. Okay, so here we go, probability of C and B. So I'm looking at the overlap of C and B here, which is this right here. So I'm going to label that one as X. Okay, and so C and B will be 3 plus X on the top. And then the probability of B is everything in this circle. So that would be 8 plus 5 is 13, plus 3 is 16, plus an X equals 10 over 23. And at this point, you can solve, right? You can put this straight into InSolve in your calculator. If you want, you can put these in parentheses and cross multiply, right? You can do anything that you want in order to solve this here, but you should end up getting that X equals 7. Okay, and so I'll go ahead, work through it. Pause the video if you need to. Work through it. Make sure that you're okay with getting that. But you should be able to get that X equals 7. So once I have that X equals 7, oh, I can't change that X anymore. So we're just going to change it into a 7. Okay, so this is now 7. Now the next question, the next part of the question, sorry, gives me the probability. Yeah, let's change colors. Ooh, that looks like fun. Okay, so we got the probability of a given C is equal to 1/3. Again, we're going to do the same thing. We're going to try to put it into our formula here, okay, up here at the top right hand. And so we're going to say that that is the probability of A and C all over the probability of C, which needs to equal 1/3. Okay, we look at the A and C overlap. Okay, so A and C overlap is right here. Okay, so that's 9. Okay, so that would equal 9 over, and then probability of C would be everything in this circle here. So that would be 6 plus 3, which is 9, plus 7, which is 16, plus this right here, which is Y. And so I should then be able to go ahead and put that in. So that would be 16 plus Y. And then at this point, you should be able to cross multiply and solve. Hopefully, go ahead. If you, again, you can cross multiply. You can put this into an InSolve. Recognize that you're solving for Y here. You could go ahead, solve it, figure it out. You should hopefully get that Y equals 11. Okay, and then once you have that, then you should be able to have most of the rest of the sections, right? So this is 11. So the only thing missing now is the total out here. And in the beginning of the question, they told us that the total is 50. So if the total is 50, then I should just be able to subtract off everything that I have so far, right? So you got 4 plus 8, which is 12, plus 6 is 18, plus 3 is 21, plus 5 is 26, plus 7 is 33, plus 11 is 44, which means that there are 6 remaining, and so this guy out here needs to be 6. And so at that point, we've answered all those questions. The last thing is to interpret your answers for A and B. Okay? So, I guess there's a number of different ways that we could try to interpret this. The first one that I would say is probably the most important one is that we look at the probability of B given A, which is 11 out of 21. Okay, let's find the overall probability of B, right? So the overall probability of B, I have 8 and 5, which is 13, plus 3, which is 16, plus 7 is 23. So I've got 23 out of a total of 50, right? And I look at these two numbers, and these are definitely not the same, right? Because they're not the same, because the probability of B given A is different from the probability of B, then we can definitely say that B and A are not independent. Okay, which is, I guess, an interesting thing there. Let's look at C. Let's just look at the probability of C. So if I add up everything inside of C, that would be 6 plus 3 is 9, plus 11 is 20, plus 7 would be 27. So that would be 27 out of 50, which is the overall probability of C. And once again, you'll notice that these two things are not the same. If I were to multiply the top by 3, I'd have to multiply the bottom by 3 to have the same fraction. So once again, not independent. B and C are not independent. And so those are kind of the things that I would look at when I was talking about my answers for A and B. And because I have all the information now, I'm able to look at that and make those decisions whether these things are dependent or independent. So it looks like, according to our Venn diagram, that investors owning properties are not independent of each other. Having a property in one city makes it more or less likely for you to have a property in a different city. All right, so that's the end of this question. Hopefully that's helpful for you, and we'll move on to another one. Watch another video if you want.